Hello everyone, welcome back to this channel. In this session, we are going to understand how we can remove outliers from a dataset. This is a very important part of EDA because before you model your data, you have to clean the dataset. And if your dataset contains outliers, then obviously the model will not be able to understand the patterns. Okay, so in this class, we are going to understand what is an outlier, why do we need to remove outliers, how to identify those outliers, and how to remove those outliers. Simple. Okay, first let me read out the definition for you. Outliers are data points that differ significantly from other observations in a dataset. That means they are not usual observations. They are far from the mean value, far from the average value. They can be high or low compared to the rest of the data. Let me show you the data set first. This is the data set. Let me copy this and paste it here. Now uh, give it a name data 7 df7. This is the dictionary ID age income. I am just converting it to the data frame as we have done this many times before. Now if I run df7, this is the simple data set. ID column, age column, income column. Now suppose you can see that in income column average 50,000, you can see near 55,000, but suddenly you get a data point which has a value of 300 or which has a value of 15 lakh, 17 lakh. So you understand that maximum values are lying near 55,000 or 60,000, but suddenly you get 2 3 data points which are far from the average value. Now if you simply model this data set, obviously, your model will consider this one also, 15 lakh also, and these values also, and it will get confused and it will not be able to predict the best result. So, simply we have to remove these outliers before we model our dataset. Okay, so clear, you get my point. Now, manually, we have understood that there are some outliers. Now, let's see it by code. If I write df7 dot describe function. Now, if I run it, it gives us the descriptive statistics count. That means total number of entries, 25 entries. This is the mean value. See here, mean value is 61,000. Standard deviation, standard deviation is also so much high here. You can see minimum is 300. 25 percentile, 50 percentile, 75 percentile, maximum is 17 lakh. So you understand the difference. 300 is the minimum value, 17 lakh is the maximum value, median is 54,000, mean value is 61,000. So you can simply understand that the data is not proper. The data has outliers. Okay, so this is the way you should think that your data set has some outliers and you have to remove them. Okay, now let's see it visually. You remember while learning Matplotlib and Seaborn, we saw a plot named box plot from where we can identify the outliers from the dataset. Box plot, let me show it to you again. Box plot is like this only. It has minimum value, maximum value, Q1 that means lower quartile, 25 percentile, median 50 percentile, upper quartile that is 75 percentile. And the difference between Q3 and Q1, this blue portion is known as interquartile range. Now if your dataset has some outliers, it may be shown here or it may be shown here. Okay. So if we plot this, we can easily identify whether our dataset has any outliers or not. Okay, so to identify this outlier, let's do the box plot. We will do it using Seaborn for now. But if you want, you can use Matplotlib also. So let me first import the Seaborn. Okay, now let's plot this. SNS dot box plot df7 and here give height income. Okay, now let's run this. See, you can get the 5 number summary. Tell me this is minimum value. What is this? Maximum value. Q1, this value is Q3. This blue portion is interquartile range. And these are outliers. So our job is done. We have identified the outliers. Now we have to remove the outliers. So now first we will calculate Q1. equals to df7 income dot quantile 0.25. Now let me run this. Let me show you what is the value of Q1. Just let's check 50,500. You can see it from here also. See, this is 25 percentile. That is lower quartile. That is what is known as Q1. Same value. Okay. So you can relate the things, right? Now we have to calculate Q3 value. Same here. Just copy paste. Change it to Q3. And here it is 75 percentile. So now if I run it, Q1, let me show you the Q3. Okay. If you want, you can check 60,000. Okay. We have got Q1 and Q3. Now our job is to find a bound, to find a lower bound and to find a upper bound. Then only we can say that those values which are lying lower bound are outliers. Those values which are lying above the upper bounds are also outliers. Okay, so you get my point. We have to find a lower bound and upper bound of the dataset. Then other values below the lower bound or above the upper bound will be simply removed. Our dataset will be cleaned. Clear? So we have to find the lower bound and upper bound. Now traditionally we consider Q1 minus 1.5 into the interquartile range. I have not calculated the interquartile range. IQR equals to Q3 minus Q1. Let me run this. You can here also directly write Q3 minus Q1, but it will be better for you to understand. That's why I'll show you what is the value of interquartile range. This is the value of the blue portion. This portion. This is 9500. Clear? So now here we can write IQR. Traditionally, we calculate the lower bound in this way. Considering 1.5 times of this blue value and subtracting it from Q1. Okay, then we will get the lower bound. Now let's write the upper bound. Upper bound equals to Q3 plus 1.5 into IQR. That means this one plus 1.5 times of IQR. That will be considered as the upper bound. So once you calculate the lower bound and you calculate the upper bound, you can identify the outliers and can simply remove them. Now let me show you the value of lower bound. This is the value of lower bound. Okay. What is the value of upper bound? 74,000. So if there are any income which is below 36,250, that will be considered as outliers. If there is any income above 74,250, that will also be considered as outliers. Clear? DF7 income less than lower bound. Now let me run this first. See here, you remember this one was 300. So this is less than lower bound. That means this data point will be removed. Okay. Okay. Same way if you want to see, just let me show you TF7 income greater than upper bound. Now let me run this. See, two values 15 lakhs, 17 lakhs. These are above the upper bound. So my job is now to remove this data point and remove these data points. Clear? Now let's write the code. DF7 income less than lower bound, or because I will consider both of them, either less than or greater than upper bound, either less than lower bound or greater than upper bound. Let me keep this in brackets. For both of them, I'll simply remove these data points. Let me first show it to you. If I run it, see, this is also true, these are also true. So all these three will be simply removed. So if I write DF7, just let's see these three values, because this is below the lower value and this is above the upper bound. So all these three data points will be simply removed from the outliers. Now I don't want the outliers, I want the clean data set. So I can simply, if I change greater than equals to That means I want all those values which are greater than lower bound, and I want all those values which are less than equals to upper bound. Now if I run it, but this is an OR symbol, so I want all of them. So I'll write and. Uh, okay, clear. Now see the income column. 44, 45,000. Okay. So I am taking all those values which are greater than equals to lower bound and less than equals to upper bound. Any values below the lower bound or above the upper bound will be simply removed. Okay, this is my clean data set. Now we have to keep it in df7 cleaned equals to. I just want to save this data set into this df7 cleaned. Okay, now simply if I just run it, you can see the data set. Fine. Now your dataset is ready for modeling. Same way, if you think that your age column has some outliers, so you can even if you want just in the dataset add some outlier, then try to do all this procedure in the same way and remove the outliers from the age column. Clear? I hope I am able to clear the complete concept that how you can simply find the outliers from the box plot, from the describe function, and you simply just find the outliers by using interquartile range, then remove the outliers. Okay, now your data set is ready for modeling. Okay, and we have already understood that it may give skewed result, it may give distorted relationship, there may be problem with model accuracy. Those are the reasons you simply need to remove the outliers, because our model is just trying to predict the data from its patterns, and outliers will give you a complete unusual patterns which is exactly not required for the modeling. That's why we need to remove the outliers. I hope now the concept is completely clear. Now we will meet in our next video. Till then, bye, happy learning.